So dear friends, as we have discussed in our previous examples that we are using some CAD data and we fed this CAD data to the printer and finally the 3D printed objects we are getting. Now I am going to take you to a powder based technologies which was probably one of its first kind when it was introduced in the form of the 3D printing or the additive manufacturing process. This started with the use of HP based printer and specifically the inkjet printer. The idea was to use a cartridge with one nozzle we are using in the inkjet. They use the two nozzles. So from the one nozzle you can see over here the powder was being sprinkled, and from the second nozzle the binder was being sprinkled. So layer of powder, layer of binder, layer of powder, layer of binder, it leads to the 3D printed parts. So the physical part you can see over here. In this particular example, I am showing you one of the component that is used in the suspension system of the truck, right? So this is the component which is basically a pressure die casting component. But just imagine, let us say I am a vendor for a big company, and the company asked me to develop this type of component for by pressure die casting, but they want to see some of the physical models. So this 3D printing can be really a aid in that case, that I can make some of the part for the physical verification and then can use the conventional process for manufacturing. So some parameters were kept fixed, like layer thickness. We have a constraint as regard to the powder material is concerned. Then the orientation angle. Orientation angle we all understand. We can put the CAD file either at 0 degree, 90 degree, or at any angle, so that can be managed. Then the curing time, in this case the 60 minute was fixed. Now this is a conventional sand casting part that you are seeing, and this is very common in our day to day lab work. The idea here is to hybridize the conventional casting with the Z cast process. Now if you see in the previous slide, if I make this component as per the technology, if I need to have a component with a 12 shell wall thickness, I can pour directly the molten metal into it. But to make a 12 shell wall thickness, I need a sizable material which is requiring a large quantity of the binder itself. Now the cost of the binder and the the material is large. Now to save that, we hybridized it in our lab and we spotted the part with the loose sand, and then we pour the molten metal into it. Now to add the value to the product, what actually we have done is we use the different shell wall thickness. Basically the ID is not changed, OD is also fixed, but on the outer side we provided the sport of the sand. So you can see as it is projected in the diagram, for the different shell wall thickness we were able to cast the different components. We tried with the different materials like aluminum, copper, different type of alloys, different type of the sands, and we try to see what is the deviation is being observed in case of the outer dia, in case of the thickness, in terms of the contour, specifically the radius part and the hardness part. And finally we are of course interested in the surface roughness. So what we observed, like in this special case, the sample was broken when I have put the shell wall below 2 and we try to reduce it for 0.5 even for some other molten metal case. So the basic idea is, for the different density of metals, we can control the shell wall thickness and basically control my process, which will lead to the more cost effective process. Then we tried it for the metrological analysis, and I am interested in the international tolerance grade. As we all know, we were able to get the IT 14, which is of course the assembly part. So specifically like the casting part, getting with all shell wall thickness in the range of IT 14 is really acceptable as an industrial solution. So in this way we can prepare the any cavity through 3D printing, and for the cost saving can collaborate with the conventional casting process. um, I believe some of us may appreciate, like one of the common thing that we do in India for the Western world as export market is the development of the lids for different gutters on the roads, or even for the domestic as well as commercial application. So making some innovative component with a small lids or an innovative lids reducing its cost will be having a great importance in our place. So I believe this information was useful to you. In my next discussion, I will show you how this 3D printing can be actually used for the development of rapid tooling for the joining application. Keep watching. Thank you very much.